Hello. So this is a video for COMP345. This is week 6, slide set 6. There's going to be only one video for this slide set. I'm going to also do a more detailed video explaining the MVC example that is available on the lab material. So that's basically going to be the same example I'm showing here, except I'm going to be going more details into the lab inside of in the lab video. So this lecture is about MVC architecture, as well as the observer pattern that is used inside of MVC. So let's go to the slides. Let me, share this here. And then start this thing here. Okay. So MVC, or model view controller architecture, is something that was invented by a man called Trygve Greenskog. He was working in Xerox Palo Alto Research Center. So that was at the end of the 1980s. So this man was working on the Smalltalk programming environment, which was one of the first full-fledged programming environments that were using pure object-oriented programming. It's also notable to be one of the first IDEs, or the system that was used to develop in Smalltalk was one of the first IDEs as we know now, using a graphical user interface. So basically this notion of an IDE as you know it now, like for example, Visual C++ was mostly invented by these people that were working on Smalltalk, which is programming language. So the idea of this is starting from the fact that they were designing the first computer that was using what we know now as a windowing system. So some people think that the notion of a window or Windows was invented by Microsoft. No, actually Microsoft took it from Apple. Some people think that Apple invented it. No, either. That was actually invented by those people at the Xerox Palo Alto Research Center, where they designed the first computer that was using a windowing programming environment or operating system, as well as it was using Smalltalk for the programming of this system. That was also the first computer or precursor to the use of the mouse on a computer. So all of these innovations were part of this, were invented in this lab. And then this MVC architecture was actually central to the whole idea of how this system was working. So this is actually a 3-tier architectural model. So you have the model, the view, and the controller. So that's what I wrote here on the board. That's what I drew on the board. I'm going to come back to that as I give more details. So essentially you have the model, who is containing the state of what you are actually computing. For example, in a game, that would be your player, that would be your map, would be your cards or things like this. All the elements, for example, of the game that you use to actually modelize and implement the rules of the game. And this has nothing to do with how the game is rendered on the screen and displayed to the user. The model is basically things that are behind the scenes that contain the state of the game. Whereas the view is another component separated somehow from the model components that is there to render the information to the user. And then you have the controller, which is there to actually control how, for example, the game is run. For example, how do you get information from the user? Is it from a keyboard input? Is it from a mouse click? So that's the controller that would actually get these events and somehow translate them in actions in the model objects. Okay, so this is essentially what is MVC. So that's nothing, it's nothing very special. It's just that it's a very common way to separate concerns inside of an application. Separation of concerns is very important because sometimes it allows you to deal with different aspects of the programming and put these different aspects in different components. Okay. Now for the model objects, what they do is they manage the behavior and the data of the application. Again, in terms of a game, you would have your, for example, your player class, your card class, you would have your map class. I'm here referring to, of course, the project we have currently in the course. That will be your model objects. And the model also, what it does, it responds to requests for information about its state, because the model object itself, for example, the player in the MVC model, is not responsible to actually display its own state. It's the view that will display its own state, the state of the player, by interrogating the player. So the player needs to expose some methods that the view will use to actually get information that it will display. The model or player is not themselves displaying their own state. This is done by the view. Then on the other side, then you have the view objects or classes. So these are there to actually render or display to the user some information about some of the model classes or objects. So it's basically a class or a class that you use to create some objects that will display some information, make the user visualize some of the information that is stored in the state of the model objects. In some cases, what's happening here? In some cases, there's also interaction that is possible depending on what kind of technology that you are using. If you're using, for example, a windowing system, very often when you open a window, there's also a listener that is connected to a window that is there to trap some events. So if you're using an architecture like this, then it's not so clear what is the strict view versus what is the controller. Sometimes there's an intersection of between these two if you use an architecture such as event-driven computation that is connected with the notion of a window that you use to display information as well as to trap events from the user. So essentially the view is there to show some information. Sometimes there's also a possibility that the view will also be connected with a component that will trap some events from the user, get some events from the user. Now, there's two different ways that it can actually initiate the displaying of the information. One of the thing about the view is that it should be notified somehow, or it should update itself. So it has to know when to update itself. So in a push model, which is the one that we'll see in this course, the idea is that when the model object is actually changing its state, then it would actually notify the view. So that's why it's a push model. The notification comes from the model object when it changes its state. It notifies the view, which then gets the new information and then outputs the information. You can also have a pull model where the view itself is actually getting information from time to time. So for those of you who know web programming, that's very often what's happening in this, in systems like this. For example, if you're using Ajax technology, then it would actually do a pull every now and then of the information, for example, in the database, because the server itself can be connected to thousands of different browsers, and it cannot push information on the browsers. It has to wait for the browser to pull the information. So that still can be an organized MVC model, but then that would be a pull model. What we see now in the course in the example is the push model. Then you have the controller. The controller receives input. It's basically its task is to receive input from the user and somehow translate the meaning of these inputs into actions in the model. Okay, so it will, for example, trap a mouse click that the user is clicking on a window at a certain place on a button or something. And then it would actually translate this event into a method being called in a model object that will initiate an action, the meaning of this action. So somehow the controller is some kind of translator. It actually directs what the user can do. And then when the user initiates an action, then it would translate this action into a call to a certain method in the model. So how do you create these three components or tiers? First, you have to create the model objects. So you create, for example, you create in the game, you would create your players, your cards, your map, and so on. You have to create them first. For example, if you want to create a view, then the view has to be connected to a model object. So the model object needs to be created before the view. Then after that, of course, you create the view and you register the view with the model object that it is actually inspecting or viewing. We'll see in more details later. Then the controller is bound to this view because the view itself is only to show information. As I mentioned earlier, so you need, the controller is there to actually direct the user into some limited number of actions. And then depending on what action is taken by the user, then the view, the controller will actually interpret that and call a function in the model. So it has, the controller somehow has to be bound to a view in order to interact somehow with the user. And then the controller is given a reference to the underlying model. So the controller is connected to both the model object as well as the view. So it acts as a intermediate party in between the view and the model by translating the user actions events into function calls inside of the model objects. So then there's this loop that is happening as there's user interaction. Okay. So what's happening is that the view will recognize that there's a GUI action. Here, the example is not going to be about a GUI, but here I'm explaining it in the form that it is most often programmed or implemented, namely using a GUI, where you have a window that is open. The window displays some information to the user and allows the user to interact with the window. Okay. So the view will have, for example, a listener, and then the listener will see that the user has clicked on a certain portion of the screen, for example, on a button. Then the pressing of the button is an event which is trapped by the listener, and then the controller will receive this event and then will interpret what should be the meaning or the action taken from this event having been triggered by the user. So you have the controller that is, let me go to that here. So you have the controller, which is actually trapping these events. It's gathering these events from the view and is basically translating these events into a meaning, which is a function call inside of the model object. So maybe there was a map, and then the user, for example, click attack on the user screen, and then this is trapped and by the controller, which is then calling a certain method, for example, attack in the model. Okay, So basically the controller translates events into actions in the model. Then eventually what's happening is as the model classes are implemented, what they do, well, of course, when you initiate an action, most often a state will be changed into some of these classes or these objects. Then what you have to do is anytime that an object that is being observed or viewed will be connected to a certain view, and then this model object would actually notify their views, which would then call a method inside of the view object, which would then react by interrogating the model object and then viewing the new information, the newly changed state information of the model object that it is viewing. Okay. And then it is displayed here, and then the user interacts again. Event goes here, which is translated into action, which makes the state change here, which then is notifying this, and basically it goes like this. As long as the user keeps interacting or the model objects are changing, this loop is continuing forever until for example, the user may specify, oh, I want to close this view, in which case this particular loop is going to stop. And of course, there can be many different views that are open at the same time. Okay, of course, then that would involve concurrency and threads and so on. We're not going to go that far here. Okay, let's go back to slides. Okay, we see that there is some GUI action, for example, clicking somewhere. This is trapped by the controller, translated somehow into a method called in the model. Okay. So as I said before, if you're using example, web design or things like this, and you have a listener, or if you're using a Windows environment, you also have a listener that is associated with every window that you have. Somehow the listener is the intermediate between the window and the controller. Okay. And then the controller will translate this event into an action to be taken by a model object. Essentially, the controller is some kind of translator that translates events into function calls. Then the state of some of them as a result of this function having been called, then some model objects state will change, which will then the model object will call notify, which will make the view update their information. Okay, so this is how the MVC conceptually how it works. So now I'm going to explain the observer pattern, which is actually the first design pattern we will see. We will see other patterns later on, but in terms of the project, MVC is a good way that you could organize your project. We will actually ask in assignment number 2 that you do some observer patterns. Okay. To organize the project. Okay, so let's go to the observer pattern. So here I'm using a predefined way to actually describe the patterns. I'll come back to that when we talk about all the patterns later on. Okay, all the patterns we'll cover in the course. Here I'm basically going fast forward to some pattern. We will come back to patterns in general later on. So a pattern has a motivation. So what's the motivation of the observer pattern? The idea is that you have a certain object that has a state, and then you have another object that wants to be able to react to this change of state of the first object. Okay. So the idea is that you need to have some kind of notification mechanism. When the first object changes their state, then it would use some communication mechanism to notify the other object that its own state has changed, so that the other object can react to this object state having been changed. Okay, so it's basically the observer pattern. It's a communication mechanism that is implemented to convey information about state change. Okay. So essentially you define a one-to-many dependency between objects, because you can have one model object. For example, you could have your map object. You could have different views on the map. So for example, you could have your map, and then you are visualizing the map as a graph. Like for example, in the Warzone game, you view the map as graphics and so on, and you can click on it. And so that's a way to actually represent the map. You can also, for example, see the same map as a list of territories, or an adjacency map, an adjacency matrix. You have different ways you can actually view information from the map. So there could be more than one view at the same time. Okay, so that's why it's possibly a one-to-many relationship between one model object and possibly many different views. So as I just explained, the MVC model, in fact, the observer pattern is this relationship between the model and the view. Okay. It's important to realize that the observer pattern does not use the word model and view. What design patterns have their own language, which is very generic kind of language. In the terminology used by the observer pattern, the model is the subject and the view is an observer. Okay. These are basically exactly the same concept, except that they use two different terms. The MVC is using model view, and observer is using subject observer. Okay, so that's the design representation of the observer pattern. So essentially you have two base classes here, which are abstract classes. You have the subject abstract class or base class, and you have the observer base class. These are two abstract classes. Then you have your concrete subjects, which are essentially the model classes. So for example, if you would do, you would implement for the map, you would implement it in using an observer, then that would be your map object, and it would need to be a subclass of the abstract class subject. Then eventually you have a concrete observer, which is essentially this object that you create that is going to display the information to the user. So that component would need to be a subclass of the abstract class observer. Thing is that the subject and observer, what they do is they implement the notification mechanism. So I was telling you about the fact that observer is essentially a communication mechanism. This subject and observer are the two classes that implement this notification or communication mechanism. And then your classes basically are reusing this communication mechanism from these two classes. Okay. Okay. Move forward. So it's essentially describing what is the role of each of the different classes in the observer pattern. So I've already explained that before. So the subject is the one that will provide, the subject class is the abstract class that provides methods, for example, attach, detach, and notify, so that when your model object is created, then it can actually attach itself to a certain view by using attach. And then it can detach itself from this view by using detach. And when its state is changing, then we'll call notify. That will notify all the views that have been attached to it. Okay. Then the concrete observer here is the one that will observe the information that has been changed in your concrete subject. How will it do it? Essentially, when you execute notify here, notify, what it does is that it goes over the list of all the observers that have been attached and will call update on each of them. Then any observer or concrete observer that you are implementing must implement update, which defines what happens, what is their reaction when they are notified that the state has been changed, which is, generally speaking, they would interrogate the new state of the concrete subject. Okay. So in terms of your game, for example, that would be your map. As the map is created, and maybe you want to attach a certain view to the map that, for example, displays the graph. Then you would call attach to connect this, for example, window that views your map as a graph. And then as, for example, the state of the map is changing because an attack has taken place, then as the state is changing, then the object, one of the objects would be calling notify, which would then make it so that notify would call update on the visualization object window that is representing this map. And then this window would reinterrogate the map and then find new information and then update it. Yeah. So you see that this is essentially a communication facility that you provide between your window and your view object, which may be a window, and your model object, and which makes it so that, for example, your map object is absolutely not concerned with visualization or creating a window. So your map class is only concerned with creating a new map and then enacting some attacks and so on. There's no such thing as mouse click and displaying things that is embedded inside of your code, which makes it more simple. Okay. For the same, from the other perspective, your window object, for example, it does not contain the state of the map. It's only concerned with displaying a map that it is connected to. The mechanics of the game is not implemented inside of your windows objects and so on and so forth. So it's basically separating different concerns, making each of these two things more simple because you have separated two complicated concerns from each other. Okay, so how does this work? At this point, I have explained much of it, but let's go over it. So first, the client class instantiates a concrete observable object. So of course, the client class, for example, would be your game engine or your game driver. Okay, so you have to create, for example, the map. Okay. Then it will instantiate an observer, for example, a window, and then will attach this observer to, for example, the map. And that is actually, it does that by using the methods that are implemented in the observable interface. The observable interface is this one here. Yeah, that's another terminology. Observable and subject is essentially the same. Sometimes observable is used, sometimes subject is used. The official term of the observer pattern is the subject. There is in Java, or there used to be in Java, the observer pattern, which was using observable and observer. So when a new observer is added to the application, all you need to do is to instantiate it in the client class and attach it to the observable object. So it's a question of creating your map, creating the window, and then connecting them together so that the communication will happen when the state of the map is changing. One interesting thing about the observer pattern is that the classes, for example, if you decide to make your map object in your game, you decide to make it a subject or a subclass of subject, very few things need to be changed. Well, it needs to be made a subclass of subject class, and it needs to call notify when the actual state is changed. We will see an example of that right now. Okay, so let's go into the code. So here, this is your base class observer. Okay, so that's the superclass. That's the superclass of the view here. Okay, so you see here, well, that's one of the things here. I'm gonna somehow fast forward into some concepts we didn't see yet. For example, this class is an abstract class. In Java, when you declare an abstract class, what you do is essentially use the abstract keyword. There's no such thing in C++ as the abstract keyword. How do you know if a class is abstract? It actually contains one method that is virtual and that has this equals 0 here, which is essentially meaning that there's no such thing as a body implemented for this function inside of this class, which is the definition of what is an abstract class. An abstract class is a class for which some of the methods don't have an implementation. So that's what this equals 0 means here. So we'll see that in much details later on, starting next week in the next slide set, or slide set number 7. Okay, so that's an abstract class. That's the class that must be inherited from every view that you will eventually create. And then, of course, what's going to happen is that any view that you create will have to implement the update method. Okay. So essentially, you can also maybe you figured that out already, but this is actually somehow equivalent to a Java interface. Okay, so here you declare a certain class, and the only thing it has is abstract methods, which is what is the notion of an interface. Interface, it has a list of methods, doesn't provide implementation for them. So it makes it so that if you implement this interface, you must implement these methods that are listed in the interface. So essentially the notion of abstract class in C++ is implemented like this. And that's how, if you want to do interfaces as Java does it, that's how you would have to do it in C++. Again, we'll see that later. Then if we want to have implementation for the constructor and destructor, then they are basically empty because this has no nothing to create or destroy. Then I have the subject class. So that's the superclass or base class that would be inherited by all of your model objects. Okay. So what it does is that it provides the attach, detach, and notify methods. That is essentially implementing the connection and deconnection of the model object with the view object, and then the notification mechanism. So you see that notification mechanism, what it does is that it uses a list of a pointer to a list of observer pointers. And then here, notify, what it does is that it just basically goes over this list of observers and then calls update on every of them. So then when when update is called on these views, then it will interrogate the object and display the new information. So you see that this attach, detach, notify, and then update here is the mechanism that you are reusing from these two abstract classes in order to become observer and subject. Then in my example here, basically I have a clock. So it's a very simple clock. So you have a method that you can use, which is start, and then it will actually call tick for a number of times equal to timed interval that is a member variable of this class. That the user will eventually input. So I've cut corners here. I'm just basically presenting the strictly necessary information. All this to say that this clock timer here is my model object. What it does is basically it's a clock. You can tell it to start for a certain number of seconds, and then it will call tick, and then tick basically increments 1 second and maintains number of hours, minutes, and seconds for this clock as number of ticks is being incremented, as ticks is being called. Tick is being called. So you see, very simple object or class. So if I want, so that's the class I had before. That's basically a clock that I had before. If I want to make it a subject, if I want to make it observable in other terms, then I actually make it a subclass of the subject class we've defined before. And then anytime that in some of the methods I have, anytime the state is changed of this clock, then I want to call notify. Okay, so you see that this code I had here before, the only thing I had to add or change in this code is what is in red underlined. So I had to make it a subclass of subject, hash include subject.h, and then call notify here. That's the only change I had to make to this entire code in order to make it observable. Okay, so you see that if I would have wanted to embed this timer or connect a window with this timer, I would have had to add an enormous amount of code in order to merge the concept of the clock with the concept of a window. Here, basically, it's using the observer pattern makes it a very much non-intrusive process of integration. Now here I have my view object, which is what I call the digital clock, sorry. So what my digital clock is essentially it outputs to the console what is the current time, as well as what is the interval or number of seconds I am now calculating. Number of ticks I am actually doing in this current call. So you see that you basically have a display method that is displaying the state of the clock, the time of the clock. And then what I need to do, if you remember, this class is a subclass of observer, which is essentially some kind of interface implemented as an abstract class or a pure virtual an abstract class in C++, which has a pure virtual method, which is the equal zero method, as we will see later. So then that basically being a subclass of this abstract class makes it so that it has to implement update. So that when it implements update here, what it does basically call my display method here. So that when the state of the clock is changing, then the clock will actually call notify. And if this was attached as an observer to this clock, then the notification mechanism will call update here, which will make the clock and the digital clock to interrogate the clock object and then redisplay the changed state of the clock. Okay. So you see that extremely unintrusive. Also, all I had to do is to say that this class is a subclass of observable or observer, and then implement the update method or include the update method in my class here, and then implement the update method. Then, okay, so this is it essentially for the observer. Okay, so here you have the observer, which is the digital clock, and then you have the observable or the subject, which is my clock timer. The clock timer is a subclass of subject, whereas my digital clock is a subclass of observer. Okay. And then they use attach, detach, and notify to communicate with one another to implement this communication and redisplay of information as this is being executed. Then here what I did, so this was for the observable pattern. Here I'm actually implementing a controller to basically make this MVC. In the observer pattern, you have the model and the view. You don't have the controller in the observer pattern. Okay, so here I'm adding a controller in between these two in order to make it MVC. Okay, so what my controller does is essentially a method control clock that basically gives some options to the user. 1, 2, 3, 4. So for example, one is set the timer start time. You enter 1 and then an integer return, and then that sets the clock hour, minute, second to the values that you have entered. So you see then that the state of my clock would have changed, and I would call notify, which would then call the update of my digital clock, okay, which would redisplay the information. So there's 4 different options that the user can enter. Depending on what is this option, then it actually is calling a certain method inside of the clock object. Okay, either a set time or a set time interval or a start. This is this translation I was telling you about before between an event or something that is signified by the user in terms of user interactions, which is then translated by the controller into a method call in the model object. Okay, so this is very simple how you can actually implement a controller. Then if you want to connect all of this together, then you basically create your clock timer, which is the model. Then you create your view, which is your digital clock. And then you connect the clock timer inside of the digital clock. If you look at the digital clock, it actually is connecting itself in the constructor. When you pass a clock timer to the digital clock constructor, it will attach itself. Okay, so that's why you don't see attach here at this point here, because attach is implemented inside of the constructor here. So create the clock model, then create the view, and then as you create the view, it will attach itself to this model object here. Then you connect the controller to the view and the model. And this connects these two things together. And then you essentially call the clock control method that I've explained earlier on that is implemented in the controller. So then that asks the user, what is it you want to do? And the user enters some information, which is then translated by the clock control method into method calls inside of the clock. So that's it for the example about the MVC. And the description of the observer pattern. You can also have some variations. As with any pattern, you can have some variations of a pattern. For example, what if you want to have and different views to be connected to it? So in the observer pattern, you can already connect n different views to one model object. What if you want to have the inverse, where you could have one view that is connected to many model objects. So what you can do is augment somehow the observer pattern and include a list inside of the in the observer itself. Somehow implement this N-to-M relationship essentially. Okay. Uh, but then you have to be careful if you do things like this. When you change patterns, if you change them too much, then it's going to be confusing to your fellow programmers. Okay, if you there comes a point where you start with using a certain pattern. If you change it too much, then it becomes not this pattern anymore. So if you claim you're using this pattern and it's not this pattern anymore, then it makes it more confusing. Okay. You have to be careful when you apply changes to a pattern. Okay, so that's it for that. You should look at the lab video that I will create if you want to have some more more detailed description of the example. So that's it for now.